Hello.
Hello. Hello,
Yeah,
Daria. Do
everything
you hear
works
me well?
perfect. Yes,
Good, good.
no
Nice to see
background noise,
you.
no nothing.
Yes, great. Good. Nice to see you. Thank you for having me today.
Perfect.
Thanks for making the time.
When it comes to the presentation, I see you have it already. So if you could switch over to the slides you're gonna show, we will still be excellent. Perfect. So if you
Yeah,
go full
good.
screen, great.
Yeah, good. You see it and you hear
Yeah.
me well, correct?
Yes.
Good. Thank you. Should I start already?
Yes. Let's get started. We meet later in the Q&A session.
Good. Thank you.
Good.
If there is any question or something, please tell me. I hope that connection will be good. Sometimes I have interruptions, so let's see. Thank you one more time for having me today. I'm presenting today here Kubota Innovation Center. We are based in Europe, in Netherlands, close to Amsterdam. And today I would like to talk about you several things. Maybe first a short introduction from my side. I have an experience in digital innovation and business transformation while working in different organizations in Europe, and mainly focusing on solving gaps and challenges through the technology and actually through the business model innovation as a main tool. In Kubota Innovation Center, I lead business model innovation and commercial partnerships with startups as well as joint development, where we actually collaborating as much as possible with ecosystem towards the future sustainability. Kubota is well known as one of the leading OEM manufacturers, quite active in the agriculture sector, which is a major for us, and I will comment on that in a minute. And I'm also, while our innovation center acts as a venture arm of the group, so we are investing in promising startups in specialty crops, vineyards, orchards, and vegetables, and hay and forage and indoor farming for now. Maybe a couple of words about Kubota. So we have roots in Japan. Our headquarters is based in Osaka. And as you can see, we are presented in the water and environment and farm and industrial machinery sectors. The second one is the leading for us, where we deploying everything today from the tractor to robots, and very much looking into the possibilities that advanced technologies are opening for farmers specifically. But our main focus is on the farmer sustainability and well-being. So we're looking for technologies that could impact on that points. Why it's like this? Because let's say the more than customer value creation and optimization of cost is a joint effort. And here technology and digitalization is enabler, where the value is created jointly together with the customer. So that's why Kubota is very much focusing on this transformation, digital transformation path, while utilizing advanced technologies and adopting them across the value chain. I would like to talk today about a couple of things. First of all, let's talk about trends, actually, which are driving these changes. And today, technology AI conference is very much focusing on part of it, but I would like to talk about what's behind. I would like to share what we are exactly doing in Innovation Center, what's our mission, and then I would like to tackle several cases through our investment portfolio and show good examples of how artificial intelligence, machine learning, and so on can support farmers, what it can do. So first of all, about the macro drivers and things that are changing the reality. As we see now, farmers are facing the highest pressure across the value chain in terms of the expectations to feed the growing population. And also, on another side, we see that costs for environmental costs are increasing, and our let's say vision towards the water usage or other like soil usage is changing drastically due to the changes that we're climate changes or other aspects of the environmental changes we're facing. And therefore, let's say that there is even more higher pressure towards that to be more sustainable, not only from the business point of view, but from the production and environment point of view. The food safety is another topic that basically as a driver from the consumer's behavior when they are expecting to know, you and me are expecting to know what we are eating, driving these changes as well, so that the less pesticides are used or less chemicals are used. And the last but not the least is the technology which is enabling practices that were not possible some years ago. In this case, I'm talking here about the declining cost for sensors, which are also driving quite a lot of this new development of AgTech. If we're talking about Gartner curve, which I think is quite well known in this case, we see that machine learning specifically is on hype now, on a peak. And specifically, this means that there are more and more cases on the market where it could be applied. And that's why from the beginning I said that, yes, it's nice to talk about the technology itself, but it's always good to know what it means as a value, what it enables. And there is a quite high expectation towards this technology right now in the agriculture sector. And the reason, from my point of view, is that more and more clear cases are coming, and there are options how to actually to change the farming practice. What it means that data collection, data acquisition is becoming a crucial part of the actual farming practices, where from different layers, you can collect the data and then apply it towards the task that farmers should deploy. And then it really depends how machine can benefit out of this and how the farmer can benefit out of this. But there is no doubt that it becomes a new normal for all of us in terms of farming practices. So in the future, it's hard to imagine that it will be without analysis and decision support during the growing season. What it also means in terms of the ecosystem and in terms of, let's say, changes that all of us are facing is that agriculture sector, AgTech sector in agriculture sector is becoming quite visible. It's not the early stage more. It's clear that there is an increase in investment for over 370% from 2013 to 2019, and it's more than 26 billions in investment now. So following this, let's say, revolution and changing farming practices is quite crucial to define the gaps that farmers are facing and that they want to improve. What means Kubota open innovation in this case? So we'll see this innovation alongside of the food value chain, due to the point that it's not more also just the farming practice. It's an inclusive process driving the food safety, driving sustainability, environment sustainability, and farmers sustainability. So our role as open innovation as a player in open innovation is to move towards this vision and let's say define the critical aspects of farmers' business and support them to make them to that they are able to achieve well-being and sustainability within their operations. Specifically in Japan, Kubota role is to expand in a different part of the value chain from production to processing and support these operations within the different tools So provide a farmer and enable a farmer to deploy this task more efficiently, to reach higher yields, to optimize cost, and so on. And I will talk about this today. So therefore, Kubota established several innovation centers across the globe, in Japan and in Silicon Valley, so that we focusing on these partnerships, due to the point that there are so many good partners in the ecosystem that could drive these changes together. And through innovation centers, we're exploring these formats of cooperation, which are not limited only to the investments, but also development and partnerships, when we are providing access to our customers and to our dealers, and together boosting the adoption of these advanced technologies and supporting this adoption. So here are some examples of our investment portfolio, and I will talk about some of them today, since they are targeting the main topic of the conference. And one of them is the TrapView, an automated pest monitoring system. Second is a C3. We will talk about the Israeli company, which is combining different layers of data to basically impact on the productivity of the farm. To influence on the productivity of the farm. And then the last but not the least is Tevel Robotics, which is a picker, apple picker. And we will talk about these issues dedicated to the labor shortage. All of these companies are utilizing artificial intelligence and machine learning and some other technologies to leverage the potential and to enable or unlock the value that farmer could reach through the data acquisition or specific applications. And that's what I would like to talk about right now. So the first case is about the TrapView. This is a Slovenian company, and the topic that they're covering is dedicated to the pest monitoring and control, due to the point that this issue causes up to 14% of the losses in yield. And different type of pesticides are utilized, and some colleagues today also during the previous presentations, they mentioned that quite often it's not clear how effective it is. Then there is a sort of changes occurring due to the resistance to these pesticides and so on and so on. So it's good to have a clear picture on actually what works, what not. And it's good to enable a farmer to control this aspect of his activities. And therefore, Kubota invested in a TrapView, and this technology is very much focusing on, let's say, enabling this remote monitoring and control through the following solution. So you have a trap that you can see here, the green one, a quite simple device, while it's not so simple due to the point that it collects the real-time data from different type of locations of the farmer and do it autonomously. And then the data is processed in the cloud and analyzed. And through that type of data, there is a possibility to create analysis towards the pest population, do the forecast specifically, and understand the difference between the different locations. Due to the point that quite often plots are located in different areas. And such a technology is now utilized on over let's say, used for over 12 millions of tons of food, produced food. And basically, the focus there is through the algorithms, through the autonomous and real-time monitoring to inform farmer on the pest pressure. Currently, how they are doing it, they are simply scouting and doing manually, and thanks to the human checkups, they consider what's going on. But you can imagine that it's a quite time-consuming task, and also human factor in terms of errors is quite high in this case. So therefore, the technology is enabling such new farming practices when decisions are taken according to the historical data and according to the real-time data. Benefits, and here we answer on the question how technology can help farmers, quite clear. So thanks to the better application, instead of manual scouting, you leverage and you make lower production costs. Then as well as the, let's say, better analysis and possibility to impact on the higher quality standards, you achieve higher yield. And then last but not the least, the risk assessment. So you can imagine that you are now informed and you can be proactive in your actions and provide better analysis and accurate analysis towards the, let's say, utilize pesticides and wrong or right decisions that you did according to them, what you used and how you used. That was the first case. The second one is from another company, which is called C3. It's also from our investment portfolio. It's an Israel company. And the case here that we're dealing with is that the farmer well-being, the farmer sustainability depends from a lot of factors. In general, it's a quite common fact that farmers' incomes in Europe are facing high pressure. And therefore, each option which is enabling higher profit or higher yield expectation are welcome. So then you can plan better the logistics, you can have more proper contracts with the downstream players, and basically impact or contribute to enhancement of the efficiency. What this technology is doing in terms of the monitoring of the tree health. First of all, it's a combination of the different data layers provided from the aerial and ground and boots on the ground sources. And then this data is interpreted again through the cloud in terms of the, for example, such cases as missing trees or underperforming trees, which are identified thanks to algorithms. And then, for example, you counting fruits per tree as well to predict the yield and to plan the further steps in your activities. And you have that months in advance, which is basically allowing you to also to structure your activities better. And it's not only about the planning. And now I will talk about maybe the benefits, the production cost. There is a high potential. So such a technology, such as startups, reducing operational expenses up to 40%, and then predicting yield is a crucial, let's say, enabling factor to the farmer to have a personalized cultivation plans, so that they understand what's going on the farm, and basically what's happening, and they respond to it rationally, not afterwards, so much more in advance. And since we're talking about tools that enabling productivity, this is one of the most best examples in that case, when technology like machine learning and advanced algorithms could enable this productivity, because they unlock the data potential for the farmer and showing the way how to apply it. Then the last but not the least is flying autonomous robot or drone. It's called Tevel. It's also an Israeli company from Kubota portfolio. And beside of the a couple of issues that I mentioned before, like pest management and yield prediction in terms of that facing issues with the income. There is another quite significant change that could happen in the future, and it's dedicated to the such a challenge as a shortage, global shortage of labor, specifically for fruit pickers. It's not only the result of the COVID-19 and travel restrictions there, but in general, the changing conditions for the farming. And then what's happening logically now is that fruits are left and then they are not sold, or they sold under worse conditions. And such a solution where the robot is utilizing the algorithms could be a complementary solution for the picking, for harvesting, due to the point that it's actually on one side supporting operations anywhere, anytime, but on another side is quite accurate in terms of the defining the fruit readiness. So how it works? Robot which is able to work 24/7, as you can imagine, picking the ripe fruits while identifying these ripe fruits first of all. It uses perception algorithms to locate trees so that it can guide itself towards the target. And then the vision algorithms, thanks to vision algorithms, it detects fruits among the foliage, and classify them and then pick them according to the ripeness as well. So such a technology actually you can imagine that it can enable many cases, but one of the most important among them is basically to tackle the labor shortage specifically as a total solution. If we're talking about the benefits, and this is one of my last slides, that we are talking about getting back control, so that control is back in the hands of fruit farmers, so that they can plan the harvesting with reliable and at low cost, and have a quite, let's say, easy planning in that case. As I mentioned, the robot could be available anywhere, anytime, and at any location where it's needed. And then we're talking about any kind of orchards specifically to apply such a technology. That was it from my side. Now I'm open for questions. I guess it's much better if I stop sharing the screen.
Yes. Thanks so much, Daria. Yeah, I think this was really a great overview on the Kubota Innovation Center, and we've already received a first question for you, so I'll go ahead with that. And the question is, what do you see as the biggest hurdle for introducing autonomous tractors and farming equipment regarding regulation, cost efficiency, and so on?
A very good question. Thank you for asking it. I think it's a combination of factors. So we're not talking about a single factor in this case. Some countries are more advanced in adoption, like for example Germany, and the cost is actually, it's about the type of machines that need to be autonomous. And then it's a good question here, what kind of task this machine is actually delivering. So you're talking about the efficiency while comparing this autonomous machine tractor with the existing way how farmers are doing it. But of course, this is, let's say, the technology, it's a future itself. Then the question is only how combination of these factors will happen and where, so that the first cases will take off from there, and that there will be a opportunity to bring it as a mass product. Specifically for us, we're testing some some concepts in Japan, and also working towards this type of solutions, since we recognize the demand from the market in terms of the labor shortage once again, and in terms of the, let's say, capabilities that such technology could bring to the farmer, to deliver something more accurate, some more tasks more accurate.
Okay. Thanks a lot for that answer, and thanks a lot again for your talk. And I think if I look on the agenda, we've almost caught up with our delay, so that's good. So thanks a lot for your talk, and anyone who wants to